Everybody. We're going to do a little bit of review. Let me say up front that I'm not feeling well today. We might end a little bit early. I know it's going to make you sad, but I got some stuff. So we're going to do a little bit of review of contraception, female contraception. And then we're going to do implantation. Then there's one more chemical methodology that we have to explore. So we're going to change our minds and talk about chemical abortives. And then we're going to start to go through early development. And I switched a couple lectures around this semester. Thursday's lecture will be on sex, primary sex differentiation and development. We might get started on that today. Depends on whether or not I make it all the way through the hour and a half today. And then after that, on Tuesday, I have to be out of town, out of the country for something. So although I rarely skip class to teach somewhere else, this one I couldn't avoid. So there'll be a guest lecturer to cover early development of the fetal endocrine glands. So sorry about that. I know you're thinking, ain't nobody else out there can cover for me. This guy can get the job done. George Bentley, some of you guys know. So here's the basic. I've truncated it a little bit. So here's the menstrual cycle. FSH and LH climb in the follicular phase with a peak in LH, ending the follicular phase because it stimulates ovulation. Ovulation occurs in an ideal 28-day cycle on day 14. After that, it's followed by something called the luteal phase, which is predominated by progesterone from the corpus luteum. So the follicular phase and the luteal phase. We talked about not all types of birth control, but basically the basic methods of chemical birth control. And most of those work, as I said, by controlling follicular development, by blocking through negative feedback, FSH from stimulating any follicles. And of course you don't get ovulation if you don't have any mature follicles. The advantages of birth control related to some of the disorders we talked about are that, for example, in endometriosis, because you're lessening the amount of estrogen when you're on a birth control pill. So you don't get as much buildup of the endometrial tissue, both in the uterus as well as an endometrial tissue that's spread about in your abdomen. In the same ways, you get some control over like PCOS and PMS because you're also controlling the progesterone levels. So remember, PMS is thought to be because of the drop in progesterone. Not so much how low your progesterone is, but the magnitude of the drop. So people who have PMS tend to have a big difference between their luteal peak in progesterone and as they approach the menstrual cycle, that drop in progesterone. So other types of birth control are progestin only. You don't build up a lining in your uterus at all. So in some cases, like a Depo-Provera, you actually might not have menstrual periods at all if you're on that treatment. The only one that was sort of different was this Plan B, which supposedly works by you have a mature follicle because you're not on birth control, but supposedly Plan B is a big dose of a progestin that blocks the LH surge so that mature follicle doesn't ovulate. Okay? And also let me say, I don't know if you guys picked up on something. I was not advocating for or against. So the development of the birth control pill is a very liberating thing for women and control of their reproductive physiology. My only points were that in making your choice is that you should know how it works. You should know what the potential side effects are. Out of principle, you should know how it was developed and who it was tested on. And you should also keep in mind that none of the chemical methods of birth control block or effective against STDs. So I'm not only a teacher, I'm a father of a 22-year-old son and a 20-year-old daughter. And those are the same things that I tell them. And also keep in mind that we don't even have a generation of data yet for even what I call the classic birth control pill. But things like Depo-Provera and Norplant, that only became available when I was in graduate school. So So we barely have 20 years worth of data to know. So those are the things that you should do. So now, though, we're going to decide we're going to get pregnant. So remember that what's happening in the follicular phase is that the estradiol is not only increasing and increasing the uterine height, the endometrial lining, but as you go through the follicular phase, the uterus, not only you're seeing more and more estrogen, right, because estrogen is going up, but the uterus is becoming more and more sensitive to estrogen because the estradiol is inducing its own receptor. So not only is the estradiol stimulating growth of the endometrium, its effect is increasing because of this increase in the estrogen receptor. At the same time, it's also increasing the progesterone receptor. So the uterus is now being prepared, the uterine lining, the endometrium, is being prepared to be supported by progesterone. During the luteal phase, progesterone predominates, but progesterone doesn't reciprocate. Progesterone stimulates its own receptor, but it downregulates the estrogen receptor. In other words, you don't want the uterus to keep growing and growing up. That's like an endometrial type situation, right? You don't want it to keep growing and growing and growing. It's big enough. Estrogen's done its job. And now progesterone is there to maintain the uterine lining. And it stops it from growing because it downregulates the estrogen receptor, because there's still estrogen. Despite not having it drawn there, you still have circulating estrogen. But the progesterone has desensitized the uterus to estrogen and sensitize it to progesterone. And it's progesterone, remember the word means progestational hormone. It's progesterone that maintains that uterine lining. The progesterone is doing a couple other things to prepare for a potential pregnancy. One is increasing the oxytocin receptor availability in the brain. In the areas of the brain that control pair bonding and caregiving for the child. Not oxytocin, the hormone, but oxytocin, the neurotransmitter in the brain. It's increasing the receptor, and it's still not clear exactly how it does that. It does that several ways. One is supposedly there's a cell surface receptor for progesterone that somehow interacts with the oxytocin receptor, the neurotransmitter in the brain. I'll try to illustrate that. Let's illustrate that here. So if there's an oxytocin receptor as a neurotransmitter, we're not talking about the hormone that's involved in orgasm, the milk letdown, and parturition we'll talk about later. Supposedly there's a progesterone receptor on the cell surface. And when progesterone binds to it, it interacts with the oxytocin receptor, the neurotransmitter receptor, and makes it more active. This is a non-classical action of progesterone. Supposedly, another theory is that there's a binding site for progesterone on the oxytocin receptor. And that makes the receptor more receptive, for lack of a better word. Yeah,
Could you repeat that?
I will repeat that. Let me finish and then I'll come back. Because the third action is supposedly, you don't even know what that means, do you? Supposedly progesterone also acts without a receptor in this regard. It intercalates into the cell membrane and it makes it more fluid. Remember, it's a cholesterol-based compound. it supposedly makes the membrane more fluid, and so the receptors now can travel more easily, which means they can find the oxytocin better. But also means that in moving through the fluid lipid membrane, they can find their second messengers to activate these behaviors better. And finally, in the brain, and then I'll repeat the whole thing. So it also increases the oxytocin receptor expression. So I'll say all four of those things. So it's increasing your sensitivity in the parts of your brain where oxytocin as a neurotransmitter regulates pair bonding and caregiving. In the parts of your brain where oxytocin regulates pair bonding and caregiving, progesterone does, at least theoretically, four things. One is it binds to a cell surface receptor, a non-classical receptor, that interacts with the oxytocin receptor and makes it more active. So one, it binds to a cell surface receptor, a non-classical receptor, progesterone, that interacts with the oxytocin receptor, the neurotransmitter receptor in the brain. Two is it may have a binding site on the oxytocin receptor that makes it more active. Progesterone may have a binding site on the oxytocin receptor that makes it more active. Three, and I believe there's really good evidence for the third, it acts without a receptor. It intercalates, the progesterone intercalates into the lipid membrane and makes it more fluid so that the oxytocin receptor is more, I guess, active, more free to find the oxytocin and more free to interact with the second messengers. And finally, it actually upregulates the oxytocin receptor in the brain itself. However, it decreases oxytocin receptor expression in the uterus. Because you don't want like uterine contractions in the middle of your pregnancy, and yes, you can't have an orgasm during pregnancy. I'll tell you a funny story about that later. It's not a TMI thing, I'll tell you. So one, it decreases, it quiets the uterus, if you will, in the uterus, and it also decreases as a hormone it decreases oxytocin released from the posterior pituitary. So it's trying to keep the uterus quiet, but it's also trying to stimulate these pair bonding and caregiving behaviors. And again, it's the behaviors that progesterone start to regulate in the luteal phase that's thought to be why you experience the PMS, because now you have these changes in this hormone that's been inducing these pleasant behaviors, and now that hormone's gone. Pleasant feeling. It's doing a couple other things that it's going to do throughout pregnancy. It's increasing blood volume. It's causing water gain. That's why some people gain weight, water weight when they're on the pill. And why you gain weight towards the end of your cycle. And that's because you're going to have to make blood and supply oxygen for this creature that's going to grow inside you by the end of today's lecture. And speaking of creatures, the other thing it does, progesterone, is it decreases immune function. So it's immunosuppressive. That might sound counterintuitive, but remember, you're going to have another organism. Oh, this says decreases immune function, sorry. You're going to have like a creature that only has half your DNA, but half of its DNA is from somebody that you're not related to. So you want to have some immunosuppression so you don't reject this organism that's going to invade your body. Good. If you don't get pregnant, as I said, the corpus luteum dies, and all that stuff goes away, and you start over. Questions? Yeah.
The progesterone only birth control, does it keep you at the levels that even cause the water retention and immune function, or is there like a level of progesterone you have to get to trigger all of this?
I do believe, I won't ask for a show of hands, I do believe there's water retention with progestin only. I don't know about immune function. I mean, and it's obviously not immune suppression to the point that you get sick all the time. That's not the point. The point is you don't want to reject an organism that, it's only carrying half your DNA. And in some cases you do, like with Rh factor. If you're Rh negative and you have an Rh positive baby, you have to go through special things when the second baby once the blood mixes. Yeah?
Does that have anything to do with like morning sickness? Or, like,
Progesterone, you just reminded me of something else. What's your name? Honey. Progesterone is involved in morning sickness. And some people think that the morning sickness and the food, that the cravings are you trying to put things in your diet that need to be there for the baby. And some people think that the morning sickness and other sicknesses, you're trying to get rid of things that are potentially harmful to the baby. Like there's smells of certain food and things like that make women ill. And that's progesterone related. The thing I forgot to say, somebody asked about the copper IUD. And I thought I knew the answer, but I didn't want to tell you something and then have to come back and tell you, no, I was wrong. So the copper IUD does not work by hormonal. It releases free copper ions into, and that changes the cervical mucus, and it makes it difficult for the sperm to get through, and it also copper is bad for sperm, so it makes them like not move and get lazy. So that's how but there are hormonal IUDs that are basically delivering progesterone, which is changing the mucus on your cervix, but also progesterone that circulates in your body. So sorry, I knew that, but I didn't want to say it and then have to come back and say, no, I made that up.
You said, what does it do to what does the copper IUD do to the...
So it releases free copper ions, and those copper ions change the cervical mucus, so it makes it a very hostile environment for the sperm, and it also, the copper ions apparently make the sperm like not move, so they can't get through the cervix and up the uterus, and as you'll see in a minute, the sperm have to get all the way into the fallopian tube to find the oocyte. Oh, sorry, that's what I thought, but I didn't want to say it without being sure. So that's what's happening during the luteal phase. The oocyte at ovulation leaves the ovary and goes into the fallopian tube. And that oocyte, or that egg, or the British say that oocyte, is only viable for 1 day. You have 24 hours to get pregnant. Now again, keep in mind though, it seems unlikely, right? You got a 1 in 30 chance. But keep in mind that sperm, my information says sperm can live in there for 4 days. Tom Carlson's can apparently live there for a week. So you can, I don't mean his personally, but so you can, even in theory, get pregnant if you have intercourse during your menstrual period. In fact, if you're trying to plan the sex of your baby, if you want to have a male, then you want to have intercourse within 24 hours of ovulation. Because the male sperm are more dense, we'll talk about why later, they swim faster, and they make their way to the oocyte much faster, but then they die. So if you want to have a girl, you're better off having intercourse way before ovulation, because all those male sperm will be dead, and the X, or the female X chromosome bearing sperm will live there longer and fertilize the egg. So you can try to plan that out if you want. In fact, if you have in vitro fertilization, there are ways, I don't know if they do it by density gradient, but they can separate out the X and the Y sperm. Like I know this when they're doing like artificially fertilizing cattle, but they separate out the X and Y sperm. Right? I think it's through some kind of density gradient because the Y sperm swim faster and the X sperm get left behind. So the oocyte pops out, and it's up in the fallopian tube. I actually didn't notice until I started teaching this class. The sperm now have to get in, and I'll let you figure out how the sperm get in there on your own. I'm not going to do that part. The sperm have to get in through the cervical mucus. And remember, the cervical mucus at this time is not very viscous. It's thick in terms of the height. So this is confusion. Other texts will say it's thick after, but that thick they mean it's viscous. Okay, so the height is thick, so it's like a sponge that's all swollen up. So the sperm swims through those little nooks and crannies, like an English muffin. It swims through the little holes. But if you squash it down, they can't swim through it. So the sperm have to get all the way through, and it meets the oocyte in the fallopian tube. The egg is fertilized. And then the fertilized oocyte wanders around. I sort of see it as like Moses in the desert or something. It wanders around for like 4 days. So you're actually fertilized for like 4 days before the egg actually makes it back into the uterus. So it gets fertilized, so it has to get fertilized by day 14, so day 14 to 15. And by day 18, it's still wandering around. A couple things can go wrong. Sometimes you'll get what's called an ectopic pregnancy. That's where the conceptus will implant in the fallopian tube. And anytime you get that, you have to abort. Because you won't live. The fetus cannot grow inside the fallopian tube. It'll burst. That actually happened to somebody's wife in the classroom. It'll burst and then the mother will die. Sometimes ectopic pregnancy can be that it goes backwards and it comes completely out of the fallopian tube and can implant abdominally. Again, that's not viable. That either that's aborted naturally or you have to have it aborted. And sometimes it can implant in a bad place, like right over the cervix, for example, and that usually can't be completed as well. So sometimes if it's overlapping the cervix, you have to have bed rest for months, you can't get up and move around, because if you imagine you have a baby with a placenta that's implanted over your cervix, that's basically trying to fall out all the time. But what you hope, if you want to have a baby, is that it implants somewhere in the uterus in the endometrium. So after 4 days, and stop me if you have questions. So after 4 days, the conceptus, the fertilized egg, turns into what's called a morula. I forget if it's Greek or Latin. It's called a morula because it's gone through several divisions. And morula literally means mulberry, like a blackberry. And I forget if it's Greek or Latin, but it looks like a little blackberry because it's a ball of cells. And here's where the hijacking begins. And by hijacking, I mean this little berry actually starts to manipulate the mother's hormones right away. And, I get in trouble when I said hijacking. And also in pointing out that the baby's actually not inside the mother. Once this egg was ovulated, the baby's actually outside of the body, right? So for example, the vagina is a pocket, right? So if you think if you pull it inside out, so the baby's like a piece of chewing gum stuck to your pocket. If you put it back in. I got in trouble once because somebody like, you can't believe college bacon with a parasite and a chewing gum stuck on. I love my kids, but that's how it is. It's one of the most beautiful times of my life is when my wife is pregnant, except for that not drinking alcohol thing. The first one, I was like, okay, I'm not going to drink alcohol with you. The second one, I had to drink in my cup. There was no sense in that. Both. Especially when I can drink enough for the two of us. But other than that, I love both pregnant. Two beautiful kids. So, what I mean by hijacking is, the little morula secretes estrogen, and somehow that estrogen allows the morula, this foreign body, to implant to uterine lining. Now, I don't know how anybody knows that estrogen comes out of the morula. I don't know how you measure that. Right? I mean, how do you find, I have no idea how people know that, but that's what all the textbooks say, that estrogen is secreted, and that makes the uterine lining, the endometrium, that means that the endometrium somehow allows, right? Because you can imagine if there were bacteria, other microorganisms, if the uterus just allowed anything to implant in there, that'd be a bad thing. But somehow this estrogen, kind of acting as a pheromone, I guess, kind of an exocrine, so somehow this estrogen interacts with the uterus and allows the mulberry to implant. So that's happening like day 18 or 19. Right? So you got fertilized day 14, day 15 after you ovulated. 4 days later, it's implanting in your uterus. It's found its way down there. I don't know how it knows where to go. Found its way down there, and it's implanting using estrogen in the endometrium. The second hijacking is the following. Over the next week, so 2 weeks after ovulation, the morula will become a blastula. Here, I have a demo. So the morula will become a blastula. Which is a hollow ball of cells. The morula, so this is the hollow, the rubber part's the cell part. So it implants, it actually sinks down into the endometrium. The hole in the middle is called the blastocele. So it's a liquid filled space, so it's like a single cell layer ball.
What was the whole?
The blastula. And the hole is called the blastocele. Not S, what's the other word that sounds like S? That's C. Blastocoel. Blastocele. And then there's something called the inner cell mass. The inner cell mass forms, and it will become two different things. Well, it'll become a lot of stuff. One is going to be the embryo, but it's also going to become the extra embryonic tissue. So that's going to be the, what's that thing called? Ultimately the placenta and the amniotic sac. That's what I was looking for. As well as the, I don't know how to say this word, allantois, which to me looks like Alan French. So the inner cell mass, part of it becomes the embryo, and then part of it becomes something called the sensitrophoblast. I don't care if you know that word, but it's this invasive tissue that starts mixing in with the endometrium. And ultimately the placenta is going to be a mixture of endometrial tissue from the mother and extra embryonic tissue from the conceptus. Conceptus. Can I say conceptus? Does that word offend anybody? Conceptus. It's not a fetus yet. It's conceptus.
How about zygote?
Zygote? Well, it's past zygote stage though. It's a conceptus. So again, the inner cell mass will become the embryo. And then part of that inner cell mass will also start to invade the endometrium and will ultimately become the placenta. Well, we're going to stop here for a second. Because one of the first things it does, this primitive placenta starts to make a hormone bring my model, but the primitive placenta was starting to make this thing called HCG, human choriogonadotropin. It has the same alpha subunit as TSH, FSH, and LH, but it has a unique beta subunit. As far as I know, it's only produced by developing placenta. If you have this hormone, you are pregnant. I think there's some weird tumors or stuff that might produce it, but normally you only have this hormone. So again, I didn't bring my models, but it turns out that this hormone, this gonadotropin, fits into the LH receptor, and it fits into the thyroid or TSH receptor. So this is the second hijacking of mom's endocrine system. Because what it does is, it rescues the corpus luteum. So instead of the corpus luteum dying, it continues to produce progesterone. And it will do that for like 3 months. Oops. And that progesterone continues to do all the stuff that I just erased. So it continues immunosuppression, increasing water retention, inhibiting LH and FSH. Well, I wasn't on the board. Inhibiting LH and FSH and GnRH. Right? That's why you can't get pregnant when you're pregnant. So progesterone, very important, inhibits GnRH, LH, and FSH. So you don't go into another cycle. It induces, and all those ways I told you, the oxytocin receptor in the brain, the neurotransmitter. It inhibits oxytocin receptor in the uterus, inhibits estrogen receptor, induces its own receptor, and inhibits oxytocin release for the posterior pituitary. Yeah, what's the question back there?
Where can HCG bind?
ACG binds the LH receptor and rescues the corpus luteum. ACG also binds the TSH receptor and causes mom to make more thyroid hormone. Why? Because thyroid hormone is critical for development. The baby needs that thyroid hormone, so it's making mom make more. It rescues the corpus luteum to do all that stuff I told you progesterone does. And it's stimulating TSH.
If it binds to the thyroid receptor, why doesn't it act as negative feedback on the thyroid hormone? Why does it stimulate it?
Because it's acting like a TSH, and it's stimulating the thyroid gland to release thyroid hormone. So thyroid hormone may be very well feeding back on the TSH and TRH, right? But you got the HCG, they hijack the whole system. Endocrine parasite. Phone's dead. 2:45. I'll do a time check. So how do you know you're pregnant? I want to tell you how you know. The pregnancy tests were developed back in 1920 or so. I have some treats I'm going to show you. There used to be a table here. So, I'll put it on this chair, I guess. And you can come up and look at this after. But one of the earliest pregnancy tests, I think Mike told me you guys learned the word bioassay in the discussion section. So the very first pregnancy test was a bioassay. And it was this frog, Xenopus laevis, and I'm sort of making this up. This one was injected with GnRH because there's a worldwide shortage of ACG. But what somebody discovered, I don't know how, in 1920, that if you inject a pregnant woman's urine into this frog, it will lay eggs. And it will lay eggs because the HCG, the human HCG, acts like an LH in the frog and causes it to ovulate. And so if you thought you were pregnant in 1940, 1945, you would literally go to the doctor and they would inject the frog with some of your urine. And then the next morning, you could see at the end of class, if there were eggs in the tank, then you were either happy or sad. That's depending on your situation. So that was one. Another bioassay, and I have the school's permission to bring animals into the no report. There was one called a rabbit test. You guys ever use the term, you're too young. You ever hear the term like, dude, did you kill the rabbit? See, like when I was in school, that was like asking, dude, like, was his girlfriend pregnant? You know what Elmer Fudd is? Yeah. The joke is lost on you guys. So if your friend has somebody pregnant, you call him Elmer Fudd. Because we were sensitive back then. So the way the rabbit test worked is, I don't have permission to fake real rabbit testing. But the way the rabbit test works was the same way to take a rabbit. So the phrase is you kill a rabbit. So they take a rabbit, and again, they would inject it with urine. And the rabbit, and this gets even funnier actually. I'm not grown up enough to tell this story without being silly. So the deal is, and the reason that this was such a great discovery was because you always had to kill the rabbit. You had to inject it with HCG. Then the next day you had to cut the rabbit open, you had to kill it, and cut it open, and look at the ovary to see a scar and see if it ovulated. Except that before this one developed, they they developed another model where they would take the rabbit and they would take the ovaries. This is a 100% true story. I can send you to the book. They would take the ovaries and transplant them into the rabbit's rectum. And then this is a 100% true story. And then they would inject the rabbit with HCG. So you had this rabbit with an ovary in his butt, right? And if you want to know you're pregnant, you have this rabbit hop around going, oops, you're pregnant. Shoot his eggs. Shoot his eggs out of his butt. That's 100% true story. So that's why this is like a really important invention, because then you can just look in there and see, okay, yeah. Frog laid eggs, and you can use the frog over and over again, and then kill it, put the egg back where it belongs. But here's how the pregnancy test works now. At least 22 years ago, this, you see this? It's a plus. This still has the HCG from my son on it. This, I'm not going to pass around because my wife peed on it. So this, see, you get a little positive thing here? See the little drips? You pee right there, and if you get a plus, that means you're pregnant. So let me show you how that works. It's a test. It's a direct assay. And it's called, and this one's not quantitative, it's qualitative. So it's an enzyme-linked immunosorbent assay. It can be used quantitatively just like the radioimmunoassay. But the way they developed this for the market, you guys saw the little plus on it, right? Is if you look at the thing, here are the components. There's an HCG antibody. There's a secondary antibody. And then there's a substrate, which can be different things. And the substrate is something that'll change color. And the secondary antibody has an enzyme linked to it on the so-called FC fragment. So the secondary antibody has an enzyme linked to it. That's why I call it enzyme linked. Immunosorbent. If you look at it, you can come look at it if you want. If you look at the pregnancy test that passed around, there's a little hole that you pee in, right? It has like a little drip thread so you know where to pee. And it has a window. And what's painted on, am I going too fast? Okay. What's painted on that window is the following. On the horizontal strip is just the enzyme. So painted on the horizontal strip is just the enzyme. That's going to be your negative control. I'll tell you why in a second. On the vertical strip, it's the HCG antibody. And when you pee into that little hole, your urine with the HCG in it if you're pregnant, and the secondary antibody and the substrate are all going to wash down when you pee in the little hole. This is quite a clever thing. So if you're not pregnant, when you pee, the substrate is going to interact with the enzyme. That's going to give you a minus. You see why they did that? Because otherwise, if you peed and nothing happened, if you didn't have a negative control, and you peed and nothing happened, you wouldn't know if you weren't pregnant or if the test just didn't work. This way you know that the reagents are working. You guys see how that happens?
Where did the substrate come from?
The substrate's coming out of a little hole you pee on. In fact, I'm going to show you. Because when I first taught this class, right after my son was born, and I was showing the pregnancy test, this woman named Helen Ying, actually that part's not true, her first name was Helen, I don't remember her last name, but she said, oh, just because you saw your wife take a pregnancy test, you don't know what it's like to take a pregnancy test, you haven't had the experience, so I took a pregnancy test, so I bought one, and I'm in the men's room at the urinal, right, and guys, you know, you're not supposed to look, but you guys know Roy Caldwell, the professor here, so he walked in, and he saw me, and he's like, dude, you know, you're teaching kids endocrinology, so here's a minus, this is how it looks if you're not. And if you've ever taken one of these, at first it looks positive, so it's whoa. Right? If you've taken one, you know what I'm talking about, because it's wet, it looks positive. But see, this is a minus one. So I peed in a little hole, and the substrate washed down and bound to the end. See, I'm not pregnant. 22 years later, I'm still not pregnant. It bound to the enzyme. See that? Harold? You Harold. Okay. Can you confirm I'm not pregnant? Right. So when I pee in there, you wash down the substrate, it binds, it interacts with the enzyme and changes color. When my wife peed on hers, what happens is the HCG comes down in the urine, and it binds to this HCG antibody. The second antibody, which is also generated to HCG, binds, and it has an enzyme. So now you got enzyme stuck to this bar, right? So you got HCG in there. So now, the substrate can interact with the enzyme because the enzyme stuck to the antibody and stuck to the HCG that's stuck to the antibody on the plate, and you get a positive. Some of them have 2 dots versus 1 dot, whatever, but they all have a negative control, so you know that the test actually worked. Does that make sense? Yeah?
Does the enzyme work with something in the urine itself, or?
No, it's interacting. Oh no, so the enzyme is working with this substrate. So sometimes it's horseradish peroxidase, or I don't know what all the colors are. I mean, there are different ones that can be different colors. Yeah?
Where did the secondary antibody come from?
It comes from that little hole you pee in. So all those components are in this hole. So when you pee here, well, except for the HCG antibody, when you pee here, the secondary antibody and the substrate are all washing down with your urine, which has the HCG in it, if you're pregnant. Yeah.
Wait, how does ACG, or how does it become negative without ACG? Or sorry, like, you know how like when
Oh,
it's negative?
the bar? Because the bar is just an enzyme, and when you pee in it, you wash down the substrate. So the horizontal one should change color every time. Because it just has the enzyme laid down on the horizontal bar. So it interacts with the substrate and changes color. But again, when you first do it, everything looks like a change. You have to wait. That's why you tell you have to sit and wait for 5 minutes. So this is just an enzyme and the substrate. So everybody, the horizontal bar, everybody will show. This, you have to have HCG in order to catch that second antibody. All right, now,